This is our third video with respect to our module on demography, and what I would like all of you to be reading, of course, is Chapter 2 in the textbook. So let's begin with the learning objectives for this third video regarding demography. There are three. We're going to move on to our third demographic marker, which is the RNI, and that stands for the rate of natural increase. I'd also, after we explain it, like all of you to be able to understand the relationship between RNI and HDI. Our second learning objective is to understand our fourth and final demographic marker, and that is the total fertility rate. And again, I want you to be able to understand it and also relate it to HDI. Finally, we will at least begin a discussion of the demographic transition model, which is a model of how societies change over time with regard to their population dynamics, meaning how do they change over time with regard to the crude birth rate, the crude death rate, and also the rate of natural increase. So let's get started. The first thing that we're going to cover is that third demographic marker. It's called the rate of natural increase, and basically what it does is it takes into account both the crude birth rate and the crude death rate. Basically, it gives us a measure of either population growth or population decline, because it takes into account both births and deaths. So the question then becomes, how do we calculate the rate of natural increase? It's actually a very simple calculation. Let's say we've got a country, and we also have data for at least 1 year. Let's say the year is the year 2011. If we know the crude birth rate and the crude death rate in the year 2011 for that country, it's very easy to calculate the rate of natural increase. And what you do is you take the crude death rate and you subtract it from the crude birth rate. Then you also need to divide that resulting number by 10. In so doing, you express it as a percent. So let's go through an example before we move on to the map that I have here at the bottom of the slide. Let's say in a particular country in the year 2011 the crude birth rate is 20, and let's say during the same year 2011 the crude death rate in that country was 5. You would subtract 5 from 20, and the result of course would be 15. Then take 15 and divide it by 10. This results in the number of 1.5% per year with respect to the rate of natural increase. That might seem like a really small number, but in fact it's not, because it's an annual rate of natural increase. So it means that every single year the population is going to increase by 1.5%, which means over the course of a decade the population might grow by something like 12, 13, or even 14%, which is actually pretty robust. So a 1.5% rate of natural increase is actually considered to be quite high, or at least moderate. So now let's turn our attention to the map that basically shows the rate of natural increase by country at a global scale. First off, we need to look at the legend and notice again that there are 4 categories. The blue represents the lowest rate of natural increase when the rate of natural increase is less than 1. The green and the yellow represent what we're going to call a moderate rate of natural increase, essentially running from 1 to 2.9. And then the red category basically represents those places that have a really high, even exceptionally high rate of natural increase, which in this case is 3% per year and above. Well, what does the pattern look like? There probably shouldn't be too many surprises here. You'll notice that in the really wealthy countries, what we call the global north, that the rate of natural increase is less than 1. It's really low. So the rate of natural increase in the United States and in Canada, less than 1. All of Western Europe, less than 1. Japan, less than 1. And also Australia, less than 1. So, to summarize, the relationship between the rate of natural increase and HDI should already be relatively simple. You could probably guess that they are, again, inversely related. As wealth goes up, the RNI typically goes down. So the way that we would talk about it then more specifically is like this. As HDI, or the Human Development Index, goes up, the rate of natural increase typically goes down. They are again inversely related. And to prove that point, we could choose some countries in the global south. So let's start over here with Mexico. Mexico, as you can see, has a moderately high rate of natural increase, and we might move as well over to sub-Saharan Africa. So just to pick one country, Madagascar or perhaps Chad, and you'll find that again, in that red category, what that means is an exceptionally high rate of natural increase. So we basically have proof then, excuse me, that the rate of natural increase and the HDI are typically related to one another. One basically predicts the other, but they are related in an inverse relationship. Now, we're going to explore exactly why that is the case a little later on. If not in this video, then in our final, fourth video dealing with demography. But there is one more thing that I want to mention. There are some exceptions to the rule, meaning there are cases where the two aren't tied together as perfectly as we would think. More specifically, where HDI is not perfectly tied to the rate of natural increase. One of these exceptions is over here in China. You'll notice that China also has a really low rate of natural increase, but it's not that wealthy of a country. In fact, HDI in China is less than it is in the United States. So why does China and the United States have basically together a relatively low rate of natural increase? It's because in China, the rate of natural increase is artificially low because over the course of the last 30 or so years, they've had a governmental policy that attempts to restrict the crude birth rate, to lower it. It's called the one-child policy. So that's going to have an effect on the crude birth rate in China, and because the crude birth rate is calculated into the rate of natural increase, it's also going to have an effect on the rate of natural increase. Another example is Russia. Russia does not have an exceptionally high HDI. It's not that wealthy, but you'll notice that its RNI is pretty low. The reason there is somewhat different. It has to do with the fact that over the course of roughly the last 20 years, Russia has been a somewhat chaotic place. Its economy, although in some cases growing really quickly, is still characterized by instability. And a lot of people there are somewhat pessimistic about the future. When people are pessimistic about the future, they often curtail fertility. They have fewer children. So there are different local reasons why this relationship between HDI and RNI might not be as predictive or as perfect as we typically think of. Now there is one other final demographic marker that we can briefly talk about. It's called the total fertility rate. It's similar to the crude birth rate, but it's different in terms of how it's measured. If you look over here at the legend to begin with, total fertility rate can range from basically 0, I suppose, that's kind of a theoretical floor, all the way up to maybe 6, 7, or 8. And what it is the average number of children over the course of a lifetime the average female is expected to have in that particular country. So in the United States, which has a low total fertility rate, the average female will have less than 2.1 children. So you're probably thinking 2.1 children, well, you can only have an absolute number, but it's an average. Other places, of course, like let's say here in the Americas, Paraguay and Bolivia, they have an exceptionally high total fertility rate, excuse me, 4 and above. So it could be 5, it could be 4.6, we don't know, but the pattern is still pretty clear. The total fertility rate as well is linked to the HDI. And here again, it is as well an inverse relationship. As HDI goes up, the total fertility rate tends to go down, and of course the opposite is true as well. So that pattern of global north versus global south can be seen quite apparently, quite visibly, and even quite dramatically on this particular map as well. Now there is a somewhat even more important idea associated with the total fertility rate that I want to draw your attention to. The number right here, 2.1, that's actually a critical threshold. 2.1 with regard to the TFR is also called the replacement rate, meaning in order for a population to remain stable, you need to have a TFR of at least 2.1. In other words, if you go below 2.1, inevitably over time the population is going to shrink. You move into what's called negative population growth. You have a negative RNI when the total fertility rate drops below 2.1. So keep in mind that 2.1 is a really critical marker or threshold with regard to the total fertility rate. The question then becomes, well, hey, if the United States is below 2.1, shouldn't that mean that our population is shrinking? Yes, it would. But the reason it's not is because of immigration. The United States absorbs a lot of foreign-born people who come as immigrants. And the same thing is true in Canada and through many of the countries of Western Europe, but also Australia. Japan, though, is a country that has a very low TFR, below 2.1, but doesn't receive a lot of immigrants. So Japan will likely be shrinking. In fact, it already is. It has a negative RNI. Okay, we are now going to move on what might be understood as the most important thing we're going to look at with regard to demography, and it's the demographic transition. I'm not going to cover all of the demographic transition in this slide presentation. In fact, we'll save some of it for the fourth video, but I want to at least provide an introduction. The demographic transition theory or model is basically a model of how societies progress or evolve over time with respect to some of these demographic markers. And it's divided into 4 stages: stage 1, stage 2, stage 3, and stage 4. Now, each one of these stages is basically a different historical era. So stage 1 is the earliest era. So in the case of the United States, we would have been in stage 1 in probably the early 19th century. So well over 150 years ago. Stage 2 and stage 3 then follow stage 1. And for the United States anyway, we arrive in stage 4 of the demographic transition in probably the immediate post-World War II period. So the very modern period, the last 40 or 50 years or so. So let's look really carefully at what this then means. Stage 1, stage 2, stage 3, and stage 4 each have something unique going on with regard to the crude birth rate, which is represented here, and the crude death rate, which is represented with the red line. We're going to get to this when we get on to the next and final video presentation with regard to demography.